Hey everyone, today we're going to be creating this interactive hippo button. We're going to take a look at how to make the eyes follow the cursor, how to make the ear wiggle on an interval, and how to make the mouth open on hover. There's also a written version of this tutorial. It's slightly different but provides a more detailed look at the design process and getting the SVG ready to use in our animation. Let's get started. We're going to start with a blank CodePen template. If you want to follow along, just go to the codepen.io homepage and click on the new pen icon in the top left-hand corner. If your layout looks a little bit different than mine, click the Change View button in the top right-hand corner and select a different editor layout. On CodePen, to make a panel take up all available vertical space, just double-click on its heading. Let's go ahead and switch over to our HTML panel and create a button element with some placeholder text inside of it. Now, switching over to our CSS panel, we'll want to cancel out the default margin that is set on the body by the browser. Next, we'll want to center our button horizontally and vertically on the screen. We can do this by setting the following on our body. Set the display property to flex, and set the align items and justify content property to center. At this point, our body is only as tall as its tallest child, so technically our button is vertically centered in the body. To make the body take up 100% height of the viewport, we'll need to set its height as well as its parent's height to 100%. Let's go ahead and do that by setting the height to 100% on the HTML and body element. And to finish things off, let's give our body a dark blue background color with the hex value of 1E313F. Next, if you haven't already, please download the SVG file that I've prepared for this tutorial. You can find the download link in the description. Once you have the SVG saved, let's go ahead and open up a new tab, then go to File, Open File, locate the SVG file you just downloaded, and hit Open. Now, let's right-click on our SVG and click View Page Source. Here, we'll want to copy all the SVG code. Close the two tabs, switch back over to the HTML panel, and paste our SVG code in between our button tags. Next, let's scroll up to the top of our SVG and copy out all of the CSS styles and make sure to remove the style element. Now, let's go ahead and paste those styles into our style sheet. Switching back to our HTML panel, spend a minute or two looking over our SVG. Notice how I grouped and named certain elements so that they will be easier to reference later on in our code. If you want to know more about how to prepare an SVG like this, head over to the written version of this tutorial as we get more in depth about the topic there. Now, you might be wondering why our SVG is not showing up. This is because our SVG is scaling to be the width of its parent, our button in this case. So let's go ahead and switch over to the CSS panel and give our button a width of 242 pixels. We should also probably remove some of the default button styles. Let's start by setting the border to 0, the padding to 0, the background to transparent, and the cursor to pointer. Your SVG should be looking a little bit better now. Now that we have our SVG in place, let's move on to the animation. Although this can be done in plain CSS, using a library like the GreenSock Animation Platform, or just GSAP for short, has many benefits. To name a couple, it'll help us squash all those cross-browser issues that you come across when trying to animate SVGs. It'll also keep our code more concise and make it much easier to edit and add to in the future. Let's go ahead and grab the CDN link to the GSAP library. You can find this by going to greensock.com, scrolling down a little bit, and copying the link within the CDN tab. Once you have this, switch back to CodePen and click the little gear icon beside the JS heading. Under Add External Scripts/Pens, let's paste our link in and click the Save and Close button to finish adding our library. We should now have access to the GSAP library in our JavaScript. Let's go ahead and switch over to our JS panel now. We're going to add a comment divider to identify what type of code this next section will be. This makes it easier to identify specific sections when scrolling through large JavaScript files. First, we want to create a timeline. This will act as a container for all of our elements that we want to tween. We can create our timeline by defining a variable named mouthOpen and assigning the output of the GSAP timeline method to it. The timeline method is able to take options in the form of an object. We'll start off by providing a single repeat option. This will specify how many times we want our animation to loop. To loop infinitely, set the value to -1. We do this so that while we're animating, we could watch our animation loop over and over again without having to refresh the page while we tweak the values. Next, let's animate one of our shapes. We'll start with the black portion of the mouth. To create a tween, we invoke the to method on our timeline, like so. This method takes a few arguments, the first being the element that you want to target, in our case, the shape with the mouth back class. You can target an element here by providing a valid CSS selector string, and GSAP will use the document.querySelectorAll method to target your element for you. The next argument is an object of properties that we want to animate, as well as a few special properties that GSAP has reserved. We'll start by setting one of those special GSAP properties, duration, and we'll set its value to 1. This specifies how long this tween should take to complete in seconds. The second property that we'll set is ease. This controls the rate of change during an animation. A visual list of the different types of eases that are available can be found by Googling Greensock Ease Visualizer and clicking on the first link. Here you can see the different types of eases offered and even create custom ones if you want. Power 2 looks good to me. Let's go with that one. Let's copy the value of this ease and go back to our CodePen. Let's paste it in as the value to our ease. The third property we'll set here is the y value. This will move our provided element on the y-axis the distance that we specify. In our case, let's move it up 70 pixels, or -70 relative to its coordinate system. The last argument that we'll pass to our to method is the point at which we would like our tween to start. Let's set 0 here, so that our tween starts playing at the very beginning of our timeline. If we hit Command S now, we should see our mouth moving up with the animation repeating over and over again. Next, let's create another tween to get our tongue moving up with our mouth. We'll start by invoking another to method. For our CSS selector string, we'll target our tongue. We'll set the duration to 1.5 so that our tongue comes in half a second slower than our mouth, giving it some perspective. We'll keep the ease the same as our mouth, and we'll move the tongue up by 70 pixels from its starting position. We'll set the final argument to 0 so that our tongue tween starts at the same time as our mouth tween. The final argument is optional, but because it is a timeline, if you don't provide a value here, tweens will play in a sequential order, one after the other has finished. By setting the starting point to be the same on all our tweens, they all begin to play at the same time. Hopefully by now you're wondering if we're ever going to address the fact that the mouth looks a little weird coming from the bottom of the SVG like that. We can fix this by using our hippo body to clip our mouth. That way, only the items that are within the bounds of the hippo body will be visible. Let's go ahead and switch over to our HTML panel and locate our mouth group. When creating a clipping path, it needs to be defined inside of a definitions element. We then create a clip path element and give it an ID. We'll name this one mouth clip. This is the value that we'll need to reference later on when we want to apply our clipping path to a shape. Within our clip path element, we want to define a shape that will be used as the clipping area. Since we want to use the body as the clipping path, let's go ahead and copy the body shape into our clip path element. Let's also go ahead and remove the class as we don't need any styles on this path. Now, to apply our clipping path, let's find the mouth group and add a clip path attribute with a reference to the clipping path that we just created. Hit Command S to save. The mouth should no longer be visible when outside of the hippo's body. Looks much better. This is a good time to move some of our values that we repeat in between tweens into their own variables. Let's move over to the JavaScript panel. Let's start by moving our ease value into a variable named easeType and our duration value into a variable named mouth speed. Having them in one place will make it a lot easier to update once we have a lot more tweens. Let's go ahead and replace our remaining values with our new variables. Since we wanted the tongue to be 50% slower than our other tween, we can just multiply our mouth speed by 1.5. You might also be wondering where these Y values come from. How did we know to move it up 70 pixels? There are a few ways we could figure these values out. First, you can move your shapes around in Illustrator and see how far you've moved them by keeping an eye on the Transforms panel. So, for instance, if your shape's starting position is Y168 and your desired finished position is Y98, we know that we need to shift our shape by -70 on the Y-axis. Another way that doesn't require Illustrator is to use CSS Transforms in the browser inspector. Simply add a temporary inline style and manipulate your values until you're happy with their position. Then copy those values over to your tween. Here's an example. Let's move our left tooth into a new location. Now, we know if we want our tooth to tween to that location, we simply add a Y -60 on our left tooth tween. You can use these methods to find values for all the different transforms: skewing, scaling, rotating, and moving. Let's continue on with our tweens. Let's go ahead and animate our teeth to move in sync with the mouth. First, we create a new tween. We target the teeth, use our default duration, and our default ease. We set our Y value to -70 to move our teeth up. Then we set the scale Y property to 1.2. This will cause the teeth to scale vertically to 120% of their original size. This is to give the teeth an effect as if they're showing more of the surface area as the mouth opens. And finally, let's set the timing argument to 0. Your teeth should now be moving in sync with the mouth. Next, let's move on to the body. Start by creating another tween and targeting the body. Let's use our default values for the duration and ease. Then let's add a scale Y of 1.06 and a transform origin of center bottom. This will ensure that when the body grows to 106% height, it will grow from the center bottom of our shape. Again, let's set our timeline position argument to 0. Let's go ahead and finish tweening the remaining face elements. To prevent this section from being 10 minutes of repetitive code, let's look at the final tweens and quickly explain what's happening. Our freckles move up 10 pixels to keep in line with the mouth. Our ears move down 6 pixels to appear like they're going behind the head. Our left and our right eyes move inwards. This gives the scene a little bit more perspective. We move our eye group as a whole down 2 pixels to hide them slightly behind the body. And finally, we move the nostrils up to reveal them a little more to give the effect of tilting back when opening the mouth. Now that we're happy with our tweens, let's work on getting our animation to trigger on mouse hover. We'll start by getting a reference to our button and storing it in a variable named button. Now, let's create an event listener for when our mouse enters the button. When this event triggers, let's invoke a function named enterButton. Okay, now let's define our enterButton function. When this function triggers, we want our timeline to start playing. To do this, let's invoke the play method on our timeline. Next, we'll create an event listener to trigger on mouse leave. When the event fires, we'll invoke the leave button function. Let's go ahead and define our leave button function now. When this function is invoked, we want our timeline to stop and play in reverse until it hits the start. Luckily, GSAP has a method to do just that. Let's go ahead and invoke the reverse method on our timeline. Now that we have our event listener set up, let's get our timeline to stop autoplaying. We can accomplish this by removing the repeat option from our timeline. Next, we'll want to prevent our timeline from playing when our code is loaded. We can do this by giving our timeline the paused option and setting it to true. Let's go ahead and save by hitting Command S. Our animation should now only trigger when a user's cursor enters the button and reverse when the cursor leaves the button. This is great and all, but our button animation seems a tad too slow. Let's go ahead and fix that by updating our mouth speed variable to something a little faster. Let's try 0.3 seconds instead. That looks much better. Now, with our mouth animation out of the way, we can work on getting one of the ears to wiggle. The idea here is to rotate our ear back and forth a few times on an interval to simulate the wiggle. Let's get started by defining a new timeline and storing it in a variable named earWiggle. To prevent our timeline from auto-playing when our code is loaded, let's go ahead and set the paused option to true. Next, we'll use a method we haven't seen before, the set method. The set method is used to set properties on your elements that you don't necessarily want to tween. So it's the equivalent of creating a tween with a duration of 0 seconds. Let's go ahead and use the set method. We'll start by targeting our right ear and setting the transform origin to center center. As before, this will determine the origin point on our shape for our transforms. Now, let's go ahead and create a new tween. Let's target the right ear, give it a duration of 0.1, and a rotation of 45 degrees. Next, let's create another tween, targeting our right ear again, with a duration of 0.1 and a rotation of 0. With these two tweens, our right ear will rotate 45 degrees on its center and back to its starting point. To make this feel more like a wiggle, we'll repeat the animation a few times. To do this, let's use the repeat option on our timeline with a value of 2. This way, once our timeline is finished playing, it'll repeat 2 more times for a total of 3 wiggles. Now let's go ahead and get our ear wiggle timeline to fire on an interval. To do this, we can use the setInterval method that's found on the window object. This method takes in 2 arguments. The first is the function we want to continuously invoke, and the second is the time, in milliseconds, the timer should delay in between executions of our function. Let's go ahead and set earWigglePlay as our function to execute, and 2500 milliseconds, or 2.5 seconds, as our delay. Now, let's define our earWigglePlay function. Inside our function, we want to trigger our timeline to play every time it's called. To do this, let's invoke the play method on our earWiggle timeline. When the play method is invoked, it begins playing your timeline forward. If it reaches the end of your timeline, it does not reset its position. So the next time you play your timeline, it will just continue playing from the end of your timeline, causing it to look like nothing is happening. Luckily, if you wanted your timeline to always start at the beginning, the play method's first argument allows you to define where you want your timeline to start playing from. Let's go ahead and pass 0 as the first argument. This will tell our timeline to play from the beginning every time we invoke the play method. You should now have a hippo ear that wiggles 3 times every 2.5 seconds. For our next task, let's get our pupils inside of our eyes to track the cursor. We'll start by making sure that our pupils are not visible when they leave the white parts of the eyes. To do this, we'll use the white parts of the eyes to act as a clipping path for our pupils. To create our clipping path, we'll use the same process we did to create our mouth clipping path. So let's go ahead and switch over to the HTML panel and locate our eyes group. Above the right eye group, let's go ahead and create our definitions element, and inside of it, a clip path element with an ID of iWriteClip. Now, let's locate the white part of our eyes, or the shape with the class of iWriteInner, and copy it over into our clip path element. Let's also go ahead and remove the class. Then, let's locate our pupil and wrap it in a group element. We're going to apply our clipping path to our group instead of directly onto the pupil. The reason for this is that we want our clipping path to stay still and our pupil to move. If our clipping path is defined on the pupil, it will move in sync with it, negating the clipping. Let's go ahead and apply the clipping path by adding a clip path attribute to our group with a reference to our newly created clipping path. Now, let's go ahead and do the same for the left eye. The next step is to figure out how far our pupil can move before it hits the edge of the white parts of our eye. To do this, we'll need the dimensions of our pupil as well as the dimensions of the white part of our eye. Let's start by switching to our JavaScript panel and taking a look at our definitions. First, we have a reference to our right and left pupil. We will use these references to get the pupil dimensions as well as to apply transforms to them later. Then, we have a reference to the white part of our eye. Because we're only using this to get the dimensions, and since both eyes are the same size, we only need to reference one. Next, we use the getBoundingClientRect to get the width and height of the white part of our eye. Then we do the same to get the width and height of our pupil. Once we have all of our dimensions, we can figure out how far our eye could move on the x-axis and the y-axis. To do this on the x-axis, we simply subtract our pupil width from the white part width and divide it by 2. Doing this for the y is the same except you're using the height values instead. If this is a little confusing, here's a quick graphic that might help. We'll only solve for how far a pupil can move left or right on the x-axis, but the same concept applies to the y-axis. Let's say our pupil is 20 pixels wide and the white area is 100 pixels wide. We start by subtracting the two values, which leaves us with 80. Then, we take that value and divide it by 2. This leaves us with 40. That means that our pupil can safely move 40 pixels to the left before it hits the edge, and 40 pixels to the right before it hits the edge. Next, let's figure out how to make the pupil in the white area be relative to where the cursor is in the body. This will give our pupil the illusion of following our cursor. For this example, we'll only take a look at the x-axis and deal with the y-axis later on in code. Our example assumes that our viewport is 1000 pixels wide and our pupil is able to move 50 pixels left or 50 pixels right before it hits the edge of the white area. The question here is, how do we convert a value from the range of 0 to 1000 to a value from -50 to 50? We can start by normalizing our current position. To do this, we can divide our current position by our max position. This will transform our range from 0 to 1000 into a range of 0 to 1. Next, let's go ahead and multiply our normalized value by 2 and subtract 1. This will give us a range of -1 to 1. And finally, we multiply our value by the allowed movement distance, in this case 50. This will convert our initial values from 0 to 1000 into values from -50 to 50. Let's take a look at one more example to really drive the point home. If our cursor is at 200 pixels on the x-axis on a 1000 pixel wide viewport, running our value through the equation tells us that we need to move our pupil -30 pixels on the x-axis. This will make our pupil in the white area be relative to where the mouse is in the browser area. Now let's take a look at how this works in our code. Let's create a new event listener on the window object to listen to the mouse move event. Every time the mouse moves, we'll trigger a function named updateEyePosition. Let's go ahead and define our updateEyePosition function. We'll start by defining a position x variable and pasting in our equation as the value. Now, because this is a function that is being triggered by an event, it gives us access to some special read-only properties. The two that interest us the most here are the client x and client y values. These tell us the position of the cursor within the client area. Let's update the current position to read the event.clientX value. The max here will be the width of our body element. And finally, the allowed movement is the value we calculated in the last step. We stored this in our x movement variable. Let's go ahead and create a position y by copying our position x. Here, we just need to change all of our horizontal values to vertical values. Now we just need to apply these values to our pupils to get them moving. To do this, we're going to use a CSS transform. Let's start by setting a transform style on our left pupil. For the value, we're going to use a template string and define a CSS translate. For the x and y values, we could use our position x and position y variables that we defined earlier. Now, let's just copy our transform and apply it to the right pupil. Go ahead and hit Command S to save. If you move your cursor around in the viewport now, the eyes should appear to be following the cursor. That's the end of it. You now have your very own interactive hippo button. Thanks for taking the time to watch the video. I hope you're able to learn some techniques that you'll be able to utilize on some of your future projects. If you feel like this wasn't enough for you and you need some more SVG and GSAP in your life, I've linked a few additional resources in the description that should keep you going. Oh, and if you have any feedback on the video or ways that I could make the next one better, send me a message on Twitter or leave a comment below.